Self weight of the slab itself. Otherwise, these other loads are the loads that are being added to it. This one is prota. We'll look at it in a few. Add load. Then we will also add wall load. Wall load. But now, what is the point here? The point is one. We only have two types of loads. Let me convince you because in the tunaanza, let me delete this load. The tunaanza, but we will discuss more about this. Dead and life, please just note that. So after selecting the slab, remember to select, you just come here, select by object type, and then you click floors, and then you click select. After that, you come here to assign. So we are going to assign, slab is a shell or a plate element. So we are going to assign shell loads. We are going to assign uniform loads, this one, uniform loads, this one. Then the load. Now, what is the dead load slab? Dead load for the slab, according to the Excel, tuliona ya kwamba we have inaitwa super embossed. That super embossed dead load, the super embossed dead load was we had one, then surfaces and finishes we had two, so a total of three. So that is what we put here. Please remember that. So then I'll click OK. Like that, as you can see now, the load is assigned. I will select again to select the previous. Assume we don't have this command here. You can just come here. This one is select all. This one is the get previous selection. You click on it, you get the previous selection, the slabs. Then you assign now live loads. I'll come here to shell, uniform, then load, change this one to live. Then live load was 1.5. I think we used 1.5. Then click OK. That is live load. Then that is live load. Now select the beams. Select the beams. Select the beams. Oh, select is already here, sorry. So, beams, then select. All beams will be selected, but remember we'll have to modify the top floor because haina wall load due. So, oh, I closed the Excel. We need it. I don't know if I saved the Excel sheet. Let me just open it to EPTM, and then it's going to be helpful. Good. So, column sizing. So for the dead load, super embossed 3, itshayeka. Then these others in 1.5. Now, slab load. Sasa sikiza hapa. We used 20% reduction factor. What is the load? As you can see now, we have two columns here. This one, this one will just give you the column sizing. But what if we want to see some load that will take to prota or ETABS? So you just you put this one, you turn this one on. Then to prota, this is what you'll take to prota structure or to ETABS. So to prota will request you to put the height of the wall and the self weight of the wall and so on, and the thickness. But to ETABS, as you can see, this one load to prota and ETABS. So at the end of the day, we need this one. This value is 7.334. Na hii ni kwa sababu tumeka 20%. Otherwise tukiweka load yote, you'll find out it's 9.11, 18. But we will just reduce this load. We don't have to put all the load as. If we put all the load, the assumption is that we don't have windows to our structure. That is the worst assumption. Don't come up with that assumption. So this one is 7.344. We'll just come here. ETABS. Now, beams selected. After selecting the beams, we will now go to assign. Beam, C shell, sasa hiyo ni frame loads, this one. Then tutasema distributed. Then ni dead load, wall load, dead load. Then imekuwa ngapi? 7.37, it is 7.344. This one. This is perfect. Then you click apply, then okay. So if you want to see these loads in 3D, because najua hapa hivi hamuzioni vizuri, if you want to see them how they appear in 3D, you can click this 3D, then come here to display, then load that we have assigned, then frame loads, then you want to see the dead loads, then click OK. So you will see all the loads kwa structure to like that. So these are the loads. So we are going to discuss this one kidogo, but at the top here we don't have the roof, the floor loads, so we are going to exclude that. How do we exclude that? Now remember we have assigned all the loads. it's a matter of excluding some loads for the top floor. Then we analyze the building, then we design, then we detail. As you can see, we have the detailing criteria here, the tab for detailing. So it will just perform the detailing. We'll export our details to AutoCAD, then we print. How do we go about this? So this is the point. This is the point. So first of all, you have to come. We have this arrow. This arrow. You have this arrow. This arrow will help you. It will help you to turn on and off things that you want or don't want to see. So right now I don't want to see the columns, and I don't want also to see the what, the floors. This one, I'll just click close. Then I don't want to see the loads, especially these loads. So you go to default, like show deformed shape. This is the default shape. This one, show and deformed shape. Deformed shape ni ile yenye after tumeanalyze utaiona inakaa utaiona tu utaiona in a few. So this one I'll just click this, then the loads will disappear. Now I want us to go to top story. This one, the top floor. This one, this top floor, which is now story 15. I'll just use the drop down arrow. This one, this floor, we don't have the walls on it. So this loads, this is what a tutatoa. How do you go about that? You select all of them like this. Then you come here to assign frame loads. Then you put 0 instead of this value. Instead of this value, 0 here. Okay. So after that, I don't know why it's not updating. Let's let me click up and down. So let me show and deformed shape again. Not deform show the load assigns. So I think up to that point, come on a shida, please, you have to let me know, because this is the most perfect way of dealing with ETABS. Otherwise, you'll over design or under design. Now, after this, tumemaliza. You come here to analyze the checks. The checks we can of course under to perform again. Check. Then we are going to prota very fast, and we will call it a day. I feel like I'm also exhausted. So no warnings. No warnings. So we'll come here to analyze. So we want to perform the analysis. To perform the analysis is to get the moments and the shear forces and deflection. Please remember that performing analysis doesn't mean that you are now getting the reinforcements. We are just getting the ni kama unajua software pia ina behave kama mtu, sorry. It also behaves like a human being. Why? Immediately in this Excel, for example, in this Excel, you have first of all to perform the sizing. Upata size ukona mkono. No, at the end, this tab is only giving you the size of the column, nothing else. Then after performing the sizing, now you'll come here. At this point, you'll have to perform the analysis. Then now you perform the design. You provide, like that's the procedure. Provide the ones as ones that could detail. So the software is also doing the same thing. We'll come here. We'll perform the analysis. This one, run analysis. So we've not saved the model since we started. So let me, okay, we can just save it there. I'll just run analysis. I'll we save. So yeah, okay, I'll just name it ETABS. Save. So immediately I click save. As you can see down here, it's now performing everything. You just, let's give it some time to one inafanya nini. Now, allow me to concentrate on one window. So this is what we call deformed shape. Hii sasa ndio tunaita deformed shape hii. Hii sasa ukikuja hapa ndio imekuwa activated. Deformed shape. Deformed shape ni ile shape yenye the building is now under loads. This is now how the building will behave. Mutasoma hizi now. Hii kujikunja ya column, this is now creation of moments to the column. Moments are created to columns in different ways. One, eccentricity. You learn about eccentricity. Two, there is a column orientation. Then three, lateral loads, the wind, the earthquake. All those things will now create eccentricity. So it depends with how you are going to join at these points. When you never commit, it will be very simple. You can also run animation of the building, wonder how it behaves under dead load. So that is how the building will behave under two types of loads, dead load and live load. Because it's network gravity loads. Yes. Yes, I think that's enough because we don't have time. Perfect. Now, this is now the deformed shape. For this deformed shape, the first thing that you must look at is the deflection. So we'll look at that one later. We'll look at that one later. Let me now after ukiangalia, when you put this cursor, you'll now see some values. These values, these are what we call deflection. But now we want to see deflection, the maximum and the minimum deflection, so that we perform the manual check to know if the building is meeting the design criteria according to table 3.9 of BS 110. Now, how do we go about that? Deflection is always checked and when the structure is under service. So we have two types of limit states. We have ultimate limit state. The ultimate limit state, this is the limit state that the structure should resist. If the loads that are placed on this structure are more than what structure can resist, of course it will fail. Inakuanga hivyo. Now, so we have two serviceability. We have two states, serviceability and ultimate limit state. So what does that one mean? We have to create load combination and redesign our building. So to create load combination, first of all, kuna hii kufuli. The moment you analyze your building, itajifunga. So you have to unlock the padlock first. So this is the deformed shape. Then go to define load combination here. Then add new combo, add the combo. Now we have two combination. The first combination is the ultimate. I'll just name it alt. Okay, ultimate, something like this. This ultimate, kuna dead and live load. I'll just select live load, this one. Then the load factor for this for the ultimate, according to table 3.5 of BS 110. Let me just get there. Table 3.5 of BS 110. Sure. Anyway, we'll just, so long as we get what we want. Now, table 3.5 should be somewhere here. So this one, this is giving you the ultimate F. F is the total ultimate design load. So this is what we call the ultimate limit state. Ultimate limit state when the building is under dead load and live load. This is for the normal conditions, like normal conditions. So for the normal condition, make sure you know this. Ultimate conditions in here. I'll just close because we are not going to use it anymore. ETABS is here. So the first one is 1.4. Then the second one is 1.6. 1.6 like that. Then I'll click OK. So this one is the ultimate limit state. Dead load in 1.4, live load in 1.6. The second one, in it serviceability limit state. When the building is under service, what is the loading condition? The dead and live load condition zote zinakuanga na the capacity ya the factor ya 1. Please, ultimate ni at about 3.5, serviceability ni 1. Then I'll just click OK. Then okay, so we have those. After this, redesign your building. Please reanalyze. I mean, because to analyze mara ya kwanza, it will take a few seconds hivi itakuwa imemaliza, haitachukua muda mrefu. But now there is a problem. We have created load combination, so it's going to do everything na ifanye ishamaliza. You can run the animation again. So that is actually how the structure behaves when it's under the two loads. Now it will give you the deflection or displacement according to in millimeters. So you can change this one. You can change the unit to anything that you want. But now, please listen to this, because this is the most important thing with ETABS and prota structure. I can only teach you that. Now utakuwa a perfect engineer out here. Now we have maximum and minimum deflection. As engineers, we always concentrate on maximum deflection. Hapa chini. Now, as you can see here, The maximum deflection is 0.494, and this one is at 8 point something. Okay, these ones are the coordinates of this building. I don't know. Tutaona na prota. In prota, when you right click on this thing, then it will show an arrow. It will show an arrow. But for this one, when you take your cursor here, it will show you the deflections and everything, the rotation and the translation. We'll discuss this one in prota. So that is it. Now, what have we done? We have analyzed our buildings. Of course, after analyzing, we have to see the loads. So to see the loads, you can come here to display. Now you can display the deformed shape. Then now the forces. The forces we can start by the reactions, the one that we are going to use for foundation design. In foundation design, we always use the serviceability limit state. If you want to know that, when you come to this Excel, the load, the maximum load unaona hapa hivi is 996 kilonewtons. This is this one 978.49. This load will now be standardized to the serviceability limit state. How? That is the load 976. So the modification, the ultimate service conversion factor, according to BSETA 110, is 1.5. But when we design using Eurocode, please, 1.37. Please. So, according to this one, we'll use 1.5. And now the total load in the foundation design is this one. We have reduced this one from 900 and something to 7. So this 7 is now action and reaction. Newton's third law of motion. Please go and read that. Now, for this one, we want to see the loads, the axial loads huku chini. To see them, what you'll do, unakuja kwa load combination. Kuna two types of load combination, service and ultimate. Tutaangalia na service because that's exactly what you want. So you click OK. You click apply. So these are the loads, but let's go to plan. I'll go to base because huko ndo zinaonekana like that, like this. So I'll apply using the table. Now, as you can see now, I don't know if I can unzoom it slowly. Good. So for this column, this is the load that you are supposed to use to perform the design of the foundation. This is the load, this is the load, this is as you can see, God is good because all the values are here. Also, we can reduce this, what is the name of this? The decimal places. You come here to option, dot this, you come to option, then you come here to where? Tolerances, I think. No, the first one, display units, this one. So you can display the kilonewton, this one. You can display this first to 2. I think 2 is just good. All this I can just display them to 2. So you can actually set ETABS to you can customize it equal on your side, like to give you the values that you want, not okay. Okay, I think that's enough. So as you can see now, this one is perfect. What you can do, you can just have a screenshot, then add it to your report, because most of the clients, because client wanakuwa na engineer yake, most of the clients lazima engineer wa client lazima anataka aone hizi values. You cannot just design this foundation umpatie a pad footing of 1.9 na yeye akiangalia according to experience anaona 1.2 is just okay. So you have to defend yourself based on what you have, otherwise kuna shida. So you can just have a screenshot of this one, then something like this, then you can save it. I don't know, imeenda sawapi, ndio hii hapa. I don't want it. So that is the point. Now another thing, let's see the reaction, the forces 3D. Now for the forces, we will do, okay, we also have the moments. You can display the moments. These are the moments, you can display them like this. So ukienda na table at the plan, you'll see them better. That's why. Now for this one, I don't think now what we, I think okay, shan deformed shape, like something like that. So we will now go here to display forces. Let's see the what, the forces here, this one, beam and columns. So we will use the ultimate. For this one, we'll use the ultimate because this is what we are going to design. Now listen to this. For column, tuliona kuna hapa, yeah, we have this one. the force acting downwards, that is the how do you call it? Compression force. That's why we have to perform compressive strength test hiyo cube test, ama nowadays Eurocode inatumia nini, the circular hiyo ingine. So column has M22 and M33. M22 for column, that is minor moments, but M33 is the, M33 is the minor moments and M22 is the major moments kwa column. Nikisema major inamaanisha kubwa, minor ni kidogo. So when you display M22, mostly the moments for the beams. Let me just click apply and see. So as you big, I don't know, we have to reduce this. We can also see the values. Let's see them using the elevation, or you can come here, show values. This one, show values. So as you can see, it is so dirty. Let me just show them using the, you can reduce this one, of course. I just increased it intentionally. You can come here, tolerances, no. This one, graphics. So this one to, let's say, something like 4. And that's still too big. I just want an elevation. I just pick one of the elevations very fast. Moment here is 18, 24, 24, 24, 24. Now, kitu tukienda kwa example, it should actually give us that. Then for this, for the interior panels, actually we don't have moments. Moment hakuna kabisa, it's negative. So, let's take an example. One, I don't know if it's good to take an example, but I wanted us to do one beam with the Excel left one, but we'll do that after doing the prota. Now, this is for the beams. So you just have to take these moments and design your beam. So for this beam unapata, you just need 2 to 12. You don't have to go more 2 to 12. Kama umeenda sana, 2 to 12 is just very okay. Because these moments does not even make sense. They are too small. Let's display moments based on dead load to 1. Ni kidogo sana, based on live load. Hakuna kitu. So there's no moment here. Remember, the spans are also too small and so on. So this one will teach you something, that when you reduce the spans, when you put the columns almost closer to each other, you are now trying to reduce the moments. And reducing the moments, that is now the process of reducing reinforcement to your structure. Please take care of that. Now, show the axial force. Axial force is zile cumulative loads. These ones, as you can see now, for this column, this one, load imetoka ni 57, 143 cumulatively. To this exactly, this is what I'm trying to mean. Cumulatively, the load for the first column ya juu hiyo ni 124. Hii yenye column mnaona hii, this one. Column ya pili ni 145, 237 hivyo. So for the Excel ni hivyo tu. Ni hii inakuja kicumulate up to the last point is 978 hivyo. So that is actually the reason as to what this software is doing. So when you move to the other grids, this is what you will see. As you can see, we have 980, minus 130s, 3 cumulatively. So if you know exactly what it's doing, you can exactly code this thing to Excel or any other software and do the same thing in a way that is understood by yourself. So anyway, that is now analysis. I just wanted you to see the graphical display of what we've done. Let's go to design. Now, as you can see, these are everything that we've just done some minutes ago. Let's go to design. So after analyzing, we have to design. So in design, first of all, we have to check. We are going to design a concrete frame. Concrete frame, this means column and beams. So we'll have to start by reviewing this to make sure that the code that we selected is correct. But as much as you selected the code uko nyuma, ETABS is the most intelligent software, ETABS and prota. So it will just remember. So for this one, I always just tell people nothing to change unless otherwise. Then design again, concrete. Then you'll come here to select design groups. Design groups, what does this one mean? Nile nyewe tunasema ya kwamba, if I design designing this beam and this beam, they are just the same. There's no difference. This one is 34, this one is 44. So utapata If we design this beam, there's no need of designing this. If you design this, there's no need of designing this. So it's like putting the elements together into a group. But for this, we are not going to do it because it's just a small building. Now, we will first of all select the design combinations. We select this, we rush huku. We select this one, pure, we peleka huku. But we don't need this one because this is for foundation design. We just need the ultimate. Then you'll come here to design. Then hit this one. You now start design. Click. So it is designing. Ishamaliza. Right now, Ishamaliza. So ETABS, what is ETABS going to give you? Areas. Sasa hiyo ndio kudesign sasa. Inakupatia the areas. So I just want to zoom into one grid. I'll just select this elevation and now study. The area for this beam is 336, ikakuja 230, hivyo alafu hapa ikapanda. We will discuss this what is. Then this beam, the area is 240. Now the question is, why 240? What is the minimum area of a column which is 200 by 200 millimeters? This is how we always calculate. I'll pick my calculator. I just want to tell you where this is. Sorry, I don't know. So for 230 formula, what we always do, you take the concrete, which is 0.2, multiplied by 0.2. Then this area, you multiply it by the minimum area of concrete, or the minimum percentage of reinforcement. And where do you get that percentage? Table 328. Where is that table? I closed the nini. Okay. Nilikuwa nimejiambia hatutaenda huku, but I think we are now here. Table 328. I'll just zoom to this table. This one is, not 28, 25. Sorry. 28 is for moment distribution, please. This one is 26. Now 25. So this one will give you the minimum percentage of reinforcement. And because I know what I want, I'll just go to that thing that I want. To get the compression reinforcement, where such a reinforcement is required for the ultimate limit state. For the ultimate limit state. Otherwise, this one is not okay with you. Just come here to simplified rules for particular cases, rectangular column or wall. The minimum percentage is 0.4 area of concrete. This is what let's do. So you take 200, not 0.2. We don't need them to meters, to millimeters. It is to millimeters. 200. What's this? Huh. So I'll take 200 multiply by 200 multiply by 0.4. 0.4 is what the code is telling us. So let's look at this. Now this 0.4 is percentage. Now this is, I think nimeanza kuchoka. 200 multiply by 200, then multiply by into bracket 0.4, then divide by 100, because that's now how to get the percentage. What am I really doing? Just what? Can you easily tell me what I'm doing? Just what? Ama alitoka? Hey. Is just what in the meeting? Wesley?
Hello, Jacob.
Just what?
I'm in.
Hey, yes.
Yes, I'm in. Yes.
Now tell me, how do we get minimum area of reinforcement? How, because this Excel, you can see here, Excel has given us 240. How do we get this 240? Because actually tumefunzwa sana. Na Wesley, you must also be here.
You are from
Yes.
a table.
No, we don't have to read. It's all about the percentage. How do we get the minimum area of reinforcement? I want you to check this. The minimum area of reinforcement is 0.4 BH. B is the width, that is 200 by 200, then 0.4%. Please do that in your calculator because I'm wondering. Okay. Now, let's check hapa nyuma kwa column. As you can see, this column is 200 by 300. Please check this, 200 by 300, not 200 by 200. So when you take 200 by 300, this one, the problem with this linear, you can't edit. Okay, just do, najua mko na calculator wherever we are. Please take 200, multiply by 200, then multiply by 200 multiplied by 300 multiplied by 0.4 over 100. And tell me what you get. Hadi tuko na nini? How do you call it?
240.
Two?
240.
Okay, sawa. Yeah. So that is how nini ETABS is doing this let's just select this beam, this column, this one. Tuone ni column size gani? This one. As you select it, first of all, it will tell us the if you right click, as you can see, it is 300 by 200. Can you see this? So the minimum area of this column, the minimum reinforcement of the reinforcement, you take the area multiplied by 0.4%. 0.4% is 0.4 over 100. So that's why it's giving us 240, 240, 240. Like hapa yote metumia minimum. Hata hii pia. If you're nikishika na ni right click, you'll find out that it is 300 by like that. But for this one is giving us 200. Right click, then see 200 by 250. Wesley fanya hii niambia ni value ni ngapi? 250 by 200 by 0.4%. Wesley?
200.
Good. So remember that this thing is using the code. Now, this is the areas. After umepata areas, now next thing, you have to convert this, for the beam also. This is the sagging areas, and this is the hogging areas. As you can see, these areas are too small. We can just use 2T12. You can just use 2T12 because the area is too small. What is 2T12? 2T12 will give you 2T12 itakupatia 226. Unaona inapita na hii ni 117 kumaanisha 226 iko sawa. So for this structure, the entire structure, you can just design your beams using 2T12. Now immediately you do you finish with this, you go now to detailing. Any question up to that point, because I want to stop at that point, tufanye prota, then detailing tutafanya zote mara moja. Now, seems like we don't have any question. You have now to take these results to detailing. But before we do this, I'll just request that we go to prota. Hey, but I'm tired, but we have to, let me just use 30 minutes to ona kama tunaweza. So prota is on. The moment you open prota, this is what you'll see. The next thing is now for you to open a new project. The new project, it's the procedure for all the softwares, including Excel. So you'll just open new project. You have to set the name of this project. I'll just name it prota or online. Let me just name it online, something like that. Then select the code. We are going to use BSETA 110, this one, UK. As you can see, we have several BSETA 110, Yakuna Malaysia. These ones are customized to their country. So for us, we are going to use the main BS, the UK one. So after that, just click OK. Click OK. Now, there is several ways of dealing with the prota, but I want us to go that way. Ya import, it will be easier for us. So I want us to import this model. The first thing is to save this model. So we are going to save this model as a DXF file, but remember this. So I'll Control Shift S to save. I'll name it prota DXF, but please don't select this 2018. 2018 haitasomeka huko. Select AutoCAD DXF of 2013. This one. 2018, don't touch it. Go for 2013, then save. That is all. Immediately after that, prota is now on. The first thing is now to bring prota to life. How do to bring the model now, to import the model? To import the model under building setout. Under building setout, please just mark this because I want to be faster. You go here to external reference drawing, this one. You click on it. Then you will add the file from the folder that is you have saved it. So I'll just add it from here. Immediately it will take you outside now to go and search for that file. It's in the desktop online, then prota. You can also import, I can also import this one, but this one will not come. Why? Because icon and how do you call it? It does not have that. We saved it as 2018. We will try that at Mutaona too. So we will select this, then open. After this, we have to make it active. Look at this. The moment I activate it, will appear. This one. So this is our model. Now, after making sure that our model is there, you have to make sure that the units are okay to millimeters. The colors, you can bring in the colors like that. The colors that are in the model, you can come up with them. Then you now click import. So under import, this is important. Please listen to this. You have to import the grid lines, the columns, and the beams. But now listen to this. This is the perfect message. Don't import beams to prota, please. So that point is well consumed by all of us. We are going to import columns, and you have several layers. Layer yetu column iko kwa layer gani? You select the layer that is in that column. So what I'll do, you can just come here, select one of the column like this. As you can see, the layer is columns. So this one is okay, columns. Then there is no text for this. Then you also have to import the grid lines. This grid lines iko kwa layer inaitwa grid line. Hivi hapa ukikuja hapa. I hope we all hear Kiswahili because now it's good to. So the layer is grid line, but what is the now this is a very big mistake. Okay, sawa. I'll tell you the mistake later. Okay, let me just avoid this mistake. Let me avoid this mistake because tuko ni kuimport tu, hakuna kazi mingi hapa. What I'm going to do, the mistake is this one. I want to put this thing, the bubble and the text, to be in one layer. So I'll just select this bubble. Then I'll just do this to make sure that they are in one layer. Because with the prota, I told you it's very simple. Control-Shift-S. Sorry. Control-Shift-S to save us. Then prota, the XF of 2013. This one is perfect. Override. Take the prota, this one, import. Then activate. Then color on, import. Then beams, as I said, don't import the beams. This one is okay. Now for the grid line, the grid name is grid line. Then for the text now, it is now this layer. Which layer is this? Bubbles. You now import the layer called bubbles. This one. You now pick the bubbles and check this. So I think this one is noted with all of us. So you just click import. This is good. Click OK. After that, I also don't want this graph. To remove this graph, you go to review, visual interrogation. I'm very fast. The good thing, I'm recording the video. I'll share it. Visual interrogation. Then I'll come here to scene settings. Then I don't want to see the graph, so I'll just remove it. I'll also want to see this compass. I don't want this. Easy tune settings. As you see, is a mana sana. Now, right now, I only imported the columns and the grids, so we don't have the beams. What I'm going to do, let us now remove this file into my import. What I'll just come here and make it inactive and click OK. Immediately you do that, it's like we are already done with everything. So what are we going to do? Come here to modeling, pick the beam. Tunaanza na kuchora beam. The beam was 200. The beam was 200 by 450. Please pay attention to this 200 by 450 update, then draw. To draw, you can just, okay, why it is not, this one is 200 by 450. Okay, you just select the entire model like, but now this one is okay, but it's going to make some mistake because of the grid lines. So look at this. This beam is 200 by 450, which is okay. The column is 200 by 450 as we imported. But now, as I said, this one is good. I will tell you the reason not today. I think this one is good. And also, for this one, Atuna He beam, if you can remember, we don't have this beam, we don't have this. So this one is perfect. I think this model is good up to that point. So what we are going to do, we are now going to push these columns to come in. In ETABS, columns will just go to their respective spaces, but it will be so difficult to create what? The grid systems. As we can see, the grids here, zimejileta tu venye zilikuwa huko. But in the ETABS, we had now to create, to select the nodes, then we use the nodes now to create the grid lines. But for this one, columns will just be okay, grid lines will just be okay, but now we have to push these columns. How do we push these columns? You select, then you use the page up and down the arrows. These arrows that are on your keyboard, the home end, page up and save on. For this one, I'll use page down like that, fix. For this one, I'll just select page down. Then this one is okay. For this one, I'll use the arrow pointing to my right, like that. Arrow pointing to my right, like that. Like that. Na inajifix yetu inasumbua. It's very perfect. Like that. Then this one I'll use pointing to my left, to my right, sorry. Right. Now, I think for the internal columns, all of them are okay. The next thing is to go to the model. Now, we have defined the columns. The columns, we defined them because we just imported the way they are from AutoCAD and they are perfect. We have defined, we don't have the shear walls. We have defined the beam. The next thing is a slab. For the slab, we will define a slab of thick Excel comes in. Select one beam, then edit wall load, this one, edit wall load. Then, as you can see right now, the dead load is 0, and you cannot put this value, this value, because this is the value that we should actually get, 7.344. But this value you cannot put it here. So what are you going to do? The first thing is to enter the wall unit weight. This wall unit 8 is a calculated value according to the settings. So the value is 2.88. I'll just put it here. 2.88. That is good. Then what is the wall height according to this? The wall height, as you can see, is the column height. I think we discussed this one with you guys. This one 2550. So this one is in meters. That is 2.55. Sorry. 2.55, something like that. This is 2550 when you convert it to. As you can see now, this one is okay. 7.344. That 4 is hidden because the other 4 is hidden because this one gives you two decimal places. The whole thickness is 0.2. That is very, very okay. And then click OK. As you can see, this beam is different to other beams. So what does this one mean? This one is loaded. Even if we go to 3D, we will now see this beam is on a wall. On top of it, there's a wall load. Now, what do? Select this beam because we want to copy this wall load to other beams. Select it, right click, and then copy wall load. This one, copy wall load. Then select the entire model like this. It will take some time because nimefungua for the first time tangu ni install. Now this is another problem with this. Nimeipeleka mbio. Okay. Inaitwa prota structure. Now with the prota, the problem is that I'm rushing. We should not rush. Prota, when you rush, this is what you get. You just have to take it slowly. I will just repeat the procedure. As you can see, unajua tulikuwa tunamaliza because tukishamaliza ni kuraise. Wenye tumefanya now they know. It's just a matter of now. Okay. Now, I just did something bad. I think in kuchoka. Immediately after exporting this file, you have to close it, please. We did this one to ETABS, but now prota imekuwa inavumilia. Okay, I'll just close this. I'll repeat, but we are going to take at least kienda sana ni 20 minutes. Then we will be done with prota. Tuta export alafu tufanye kila kitu tutoke hapo. Now the procedure is the same. I'll open. I'll just name it okay. Then BS. Okay. Now, please, while working with prota, especially to install, you have to at least restart your laptop before you start working on any software. Any. I'll first of all remove this grid system. You come here to review, visual interrogation, scene settings. I'll just remove it like this. I don't want it. Then I'll go home, building set out, and then I'll come here to external reference. I'll load the application, prota, open, activate it, come up with the color import. I'll make sure I don't want the beams. I'll have the grid bubbles, this one, and check this, click OK, then import. After doing this, I don't want the close. I don't want to see the plan, so I'll just click OK. Immediately, our columns are there. Imagine in those few seconds, share under columns in a grid system. So the only thing in back in to column to Mazan beams, and this one is a matter of dragging. So 200 by 450. I'll just be faster kidogo. So I think this is good. I'll remove this, I'll remove this, I'll remove this. Then what I'll do, I'll now push the columns. Push it this one down, this one down. This one, I'll push it to my left side. Left. Oh, we should be having a column here, a beam here. So okay, I'll just put one beam there. No, after this, I'll go back and put the beam 200 by 450, 200 by 450, 450. So I'll just drag, or you can just draw. And then I'll push this one, push. Sorry, like that. So after this, I'll press Control S to accept that whatever I have done is correct. That is how you work with Prota. You at least give it time to think, especially this cracked version. Sorry. So slab. To the slab, I'll put 150 as we had done before, and then I'll come to loads. I'll put here 3 because this one is already calculated. This one is 3. Then after that, you just start putting your slabs like this. As you can see, if given a plan, you can design that plan within 1 hour or 2 hours. Unaweka kwa AutoCAD, then you print and submit. There's nothing big. So because I had done everything here, I'll just right click on this, edit wall load. This one was 2.88. Then this one was 2.55. Then this one was 0.2. Then I'll click OK. Let me check. Edit wall load. This one is okay, perfect. Now, as I said, saving is good. That is how, by the way, with any software, you just have to do something. So after that, I'll now right click. I'll copy the wall load. It's now copied. Now I'll minimize this. Then these are the beams. Instead of selecting the entire model, because that is what will interfere with our. I'll select all the beams. I'll select the first beam, then hold Shift, then select the last one, then right click while inside here, then paste copied wall beam loads. This one. So it will ask you. I will not read, but just say yes. So it is very fast. It's now everything is now done. I'll just go to 3D and see what we've done. This is perfect. This is perfect. So after doing this, you have to raise your structure because we have already done everything. You'll go here to building set out. Then you'll come here to story operations. Then you'll insert stories. This one, insert story. Remember, we had a total of 5 columns, so 5 stories. I'll just put 5, then okay. Okay. Now, after inserting stories, as you can see, it's up to 15 meters what ETABS has been giving us. You'll come back here and generate story. We want to use this one to generate flows to add to which story. This is the source story. The target story will be now number 2, 3, 4, and 5. Then click OK. Then close. So as you can see right now, everything is perfect. The building is good. But now we have to, let me just save. After doing this, now we will go to story 5 and remove all these wall loads. So what I'll do, I'll just go to plan, then story 5, double click on it. So this is story 5. Right click on this story, then what you'll do before doing this, you can just click this. As you can see, this one is selected. Then shift like that. Then you have selected all the beams. Then right click, then delete manual loads. These ones. Then okay. I think this one is noted with all of us. I'll go to 3D. Okay, these loads are still there. I don't know why. I'll select this. I'll select all of them. Then I'll right click, delete wall load. This one, manual load imekata to tender wall load. Like that. Now, after that, please save. But the good thing with the Protas, you can see it responds very fast. Even in saving, it does not take even a single second to think. Now, after this, the next thing is now to go to loading. Now, under loading, you have to define the load cases and the load combination. I'll just click this one. Then we have to go to the loading generator, this one. At this point, we don't have we don't have to introduce the horizontal loads or the lateral loads. So I will uncheck this. Then I will come back. For this one, you have to select these factors. By default, these ones are for ultimate limit states, but we have also to introduce a factor for the serviceability limit state for foundation design. So I'll just check this box for serviceability, then introduce here one. Then I'll now click OK. You can as well come up with one pattern load, which is not even important, but this one is okay. Click OK. Now, as you can see, we have 4 load cases, load combination, I mean. The first one is the pattern load, of which we can rely on. This one is the serviceability. The second one is the ultimate load, as you can see, 1.6 and 1.5 and 1.6. Then these ones are called pattern loads. I'll just delete them. I don't need them. Like that. Then I'll click OK. We have serviceability and ultimate. Then click OK. After that, we don't have seismic, we don't have wind. We'll now review our model and do all the settings that we wish to have. So I'll just come here to building check. Then I'll just start checking the model. If we have any errors, we'll have to remove all those errors. Otherwise, as you can see, the building is checked and the number of errors is 0. I'll just close. Then after that, now we have to come here to analysis. As you can see, we are already in analysis mode. Now, building analysis. For the building analysis, we have to set the parameters. So for these parameters, we'll come here to, we will start by the pre-analysis. Pre-analysis means before analysis, do something. So what are we supposed to do here? We'll edit materials. The default material here for the column, we said we are going to use class 25, that is C2530, that is class 30 for columns, I mean. Then for the beams, we'll use class 25, which is this one, it's on, okay. For the slab, class 25, that's okay. We don't have ribbed slab here. Then for the main, for these ones, for the grade of concrete, for the grade of steel, we are going to use or D, so I'll just use T for my case. Then I'll apply to all. Applying to all means we want this 410 to change, all of them to change to 500. So I'll just click, then all of them are now okay. Columns. Now, under columns, the reinforcements that you feel like this building should actually have. From ETABS, as we also, it's almost using the minimum reinforcements. So what we are going to do, we can just use, so I will select deselect. We can just use 40, 12 or 40, 16. So I'll just use here 40, 16 and 12 for that building. It will just request the 12 and 16. I'll use this one. Then for that is for the columns. For the beams, we will use T12 as you saw from ETABS. There's no need to suffer. Let us just use T12 because that is what ETABS gave us. Then for the slabs, we always use T10. I'll click OK. Then for the links, For the links, we always use T8 unless otherwise. Okay, now that is okay. This is now for the superstructure. Just for to understand this can teach us this well. Superstructure. Now, what about substructure? For the substructure foundation, the class of concrete will assume 30 for like just like for for the other material. Then for this one, we'll use 500 type 2, 500. Links will also use 500. Then the foundation rebars will use T12. T12 is the minimum for foundation, so we'll just go with that. And we don't want T16. T12 is just work. Then for foundation, we will discuss this one, but for foundation, we always don't need shear reinforcements unless we have some punching shear, face shear, and the transverse shear. So this one is done, and this one is done. So under pre-analysis, we'll go to project parameters, the codes. We will set all these codes, but everything is set. We don't have earthquake, we don't have wind. For foundation, we'll put the allowable bearing capacity because prota is going to do foundation design. So assuming that this building is, assuming that we are going to set this building at Arusha, where we have some rocks, Arusha, Tanzania, we can just use 250. Then for the lateral, we don't have the lateral load, so I'll just click OK. Then for the loading combination, remember we already came up with these load combinations. For the wind, we don't have wind. Go to model options. For the model options, sasa hapa msikize, please. From clause 3415 of BS at 110, I think I closed the BS, but you just go to that clause. We have 3 types of beams. Kuna flanged beams. Table 3.9 kwanza, it will give you rectangular beam and flanged beam. What is a flanged beam? A flanged beam can either be an L beam or an T beam. But now, is it economical or uneconomical to design our beams as flanged or rectangular? I'll just answer this. It is good because of time. Don't go for this. Let's use rectangle for today. Then we don't have shear walls, we have slabs. So we will mesh all the slabs. To mesh all the slabs, I think I discussed with most of us about meshing. To mesh the slab is like to come, if we assume this is the graph, for this graph, assume this is the slab we are talking about. So for this slab, we have divided this slab into small particles, some cubes. Kama tiles kwa nyumba. So we have some cubes hapa hivi. So for this is now what we call meshing. From the entire panel, we are now coming up with some small panels for easier fair analysis. That is finite element analysis method. So for this one, we are going to create the mesh. So for this one, for finite element analysis method, we are going to check this one include slab in building model. And then the stories to be meshed, we are going to select all the stories. We have to select all the stories that with what? With the slabs. So I'll just select all of them because all of them have slabs like that. Then after this, you can come here to some settings. There's nothing here to change. Now go to analysis. Pay attention. Analysis. Remember here we can perform building analysis, but remember we performed this one. At the end it told us there's no error. No error, this is perfect. Now, perform building analysis. But now in some softwares like -10, we always perform what we call eigenvalue analysis. Eigenvalue analysis is mostly used while calculating, while designing the building against earthquake forces. So, as you can see, mass calculation and mass. Remember, earthquake will only affect your building based on mass. Then wind will only affect your building based on the area because wind inakuja like pressure, like force acting per unit area. So that's pressure. So because we are not designing our building against the earthquake, don't include this, then perform analysis. For this one, I don't want to perform analysis only. I want to perform analysis, then at the same time, I perform design. How do I do this? You'll check columns at the beams, then you'll tell it to design here mwisho. After that, we don't have steel members, so we are only selecting this, then click building analysis. So I think in the next 10 minutes, tutakuwa tunafunga meeting because we are almost coming to the end of prota structure. So you will realize if you mastered these ways of moving from AutoCAD to ETABS to prota to, there is another important software inaitwa aje, Tekla structural designer. Please, that software, if you request me, I can easily send it to you, because I know the versions are not available right now, but